graduate student, and I am here to share with you some aspect of my research, and I hope to challenge you to think of missing data in a different way. Specifically, I am going to introduce something called the missing data perspective, and how this is relevant in the era of big data. So as a project statistician, I have always been asked this question: do we have missing data? And generally, this is what we mean when we talk about missing data: missing values in rows and columns. However, I propose that in the era of big data, this is kind of boring, and it's more meaningful to ask, do we have complete data? And even better, if we ask, complete for what? So I'll come back to this question. If you guys remember this article by Kenneth and Victor, they laid out a very great vision about the future with big data and the promises of big data. However, I think there's one flaw in the argument, which is the n equals all argument, which is we will get the information of the population, so we don't need samples anymore, and we can just do analysis on the population. In some case, we do have n equals all. In some, let's say if you work with rats or you work with a restricted population. But here I have some examples that I would like you guys to consider. So this is Facebook. Facebook has more than 1.11 billion users. Very good. But if you consider the world population, that is 7 billion, so Facebook's users are approximately 1/7 of the world's population. And if you pay attention to their terms and agreement, they actually have 1/5 of the world's population, because you have to be above 13 to sign up for Facebook. So it's pretty impressive, 1/5 of the world's population. LinkedIn has about 300 million users. And this is an article from the BBC. Apparently, a lot of their users are fake profiles. And one easy way to spot that is to look for the stock photo. Oops. The stock photo with the pretty girl. Like that. I'm sure this is not a problem just for LinkedIn, but I'm just using it as an example here. So, do we have n equals all in the examples that I provided? I will argue no, but if you compare it to the world population. But let's say if we imagine a time where everyone has a LinkedIn profile and everybody has a Facebook profile, then do we have n equals all? I would still argue no, because we will have n greater than all. We have duplicates and we have fake accounts and things like that. So in terms of completeness, no more and no less, I don't think we will ever get that complete data that we talk about so often. Again, the better question really is, what do you want to do with the data? So supposingly, if your company is looking to expand worldwide, how good is the data from Facebook? So this is a world map, an estimate of the most popular social networks that is used in the world up to January 2016. So we can see that Facebook is doing quite well, represented in many of the countries. But if you're trying to sell to Japan, for example, you may not want to rely solely on Facebook data. Japan's most popular social network is Twitter, and China, in red, uses Qzone. Russia has their own, and some other countries have their own specific networks too. So what about LinkedIn? This is an estimate of their reach per continent. So most of the users are based in North America. And again, if you're looking to sell to Africa or Asia, you may not want to depend solely on data from LinkedIn. So this is not a new problem, right? A lot of you will have an intuition of what I'm talking about. So traditionally, this problem is called the sampling problem. So this is Truman holding a newspaper that predicted his defeat, but actually he won the election. The analyst in this case works for Literary Digest, and they didn't know that their data was not complete, and they did a prediction model, and they got it wrong. So what I'm trying to say here, just as there is no free lunch, no best model for machine learning for every single problem, there is also no complete and best data. But is this a very bad situation, a doom and gloom situation? I would argue maybe not. You see, traditionally, the problem that I have mentioned is considered a data missing not at random problem. So this is just a fancy term to say we don't know that we have missing data. Therefore, we didn't do anything to correct for that, and we may have made a garbage model. However, what if the analysts at the Literary Digest knew that the data they have at hand was not complete? Just the knowledge of knowing that your data is not complete, helps you ease from a hopeless situation to a potentially hopeful one. So basically, terminologically speaking, moving from missing not at random to a situation where your data is missing at random. The advantage of this is that when you are missing at random, if you think your data satisfy the assumption of being missing at random, you can use statistical methods to correct your model. You can use methods to estimate the bias, improve the accuracy. There's a lot of things you can do. But first, you have to know that your data is not complete. So these are the, at a very high level, steps to kind of move towards a better place to be. First, you ask yourself, is your data complete? And if you think no, or if you just like to explore further, you can seek relevant data and combine them. There's many ways to combine data. You don't really have to have a neat table with everybody on the same, not everybody, one person each row. There are probabilistic matching, sample matching, a lot of ways to combine data from different sources. Secondly, once you combine the data, you could create predictors to predict the missing values. And with that, you can start to populate your bigger and more complete data set. In my opinion, we should respect the variability when we impute these values. So not to just put a predicted value in, but there's many ways to do that. Big data has different promises for different people, depending on what you do, depending on industry. For me, this is one of the things that resonates the most, is the ability to use information, to use more data, to understand what you don't know, and to make better models. So thank you, and this is my presentation.
Question? Maybe you just put up the last slide again?
This one?
So impute, I guess, is the word compute, but to impute, it means to predict. Is that the idea? It's a predicted computation?
Yes, so you predict the value however you choose to, and you put it into your database.
So compute is like there's a single answer. Impute is predicting or generating a value on a statistical basis. Is that what I'm hearing?
Yes, you can do that, or it could be a constant. So if you have reason to believe that everyone that's missing is missing in the same way, you could just put in a constant.
I see. Okay, cool. Thank you.
Why would you want to put data, missing data in a database? That's what's not clear.
Right.
Why not just assume you don't know it and
So it's
factor it into your model?
I think the idea is a little controversial. I'm not putting missing values in the database. I am proposing to put imputed values into the database.
They're an augmentation? Is an augmentation?
Yes.
Okay.
So if it's missing, usually you will see the NAs, right? Or no, depending on the software.
We'll have a second table that ends with underscore imputed? Is that what you're saying, won't mingle with the source data?
Sure, you could do that. So if you're using probabilistic imputation, so like multiple imputation, you'll have maybe 10 tables with different imputed values. You run your model on each of the 10 tables, and then you average your model's estimate. So that's one way you can respect the variability. But you don't have to do that. That just depends on the situation of your missing data.
So the problem you're describing is,
Yeah.
People have been facing this problem in drug industry for a long time when they do clinical trial, and it's a very common problem because they're talking with human beings and sometimes they don't have the data.
Yeah.
And so over the last 20, 30, 40 years, people have come up with various ways of dealing with it. And I'm not in this field. Has there anything significantly happened recently than what people used to do before?
Right. So traditionally, this is where I work in traditionally, like this, right? We have missing data because the participants didn't show up, they drop out from the trials, etc. There's many ways to deal with that. You can do imputation, you can just get rid of the rows depending on the type of missing data you have. The difference with what I'm talking here is that if you don't know you have missing data, you can compute. So the first step is to find out